time travel. In 1895, writer H. G. Wells wrote his groundbreaking novel, The Time Machine. It was after this that the phrase time machine became popular. A machine that can take you into the future as well as the past. With it, you can travel through time. Although this novel was fiction, a science fiction novel, but several philosophers and physicists were inspired by it. Not only were serious research papers written on time travel, but many films were also made. Is it possible to do time traveling? Is there any way for time traveling? There are many concepts. Number 1. The first is the one-way travel to the future. You travel to the future and you can't return. Number 2. Instantaneous time jumping. A person can jump from one point in time to another instantly. Number 3. Traveling at the speed of light to travel through time. The question is, among all these concepts of time travel, which way is actually possible today? Broadly speaking, there can be two types of time travel. One is to travel into the future, and the other is to go back into the past. In today's video, let's understand the concept of time traveling scientifically. Let's talk about traveling to the future first. The scientific explanations and theories of traveling to the future are derived from Albert Einstein's theory of special relativity. The concept of time dilation was introduced by Einstein. Before Einstein, it was believed that time is constant, whether you're on Earth, or on Mars or near a black hole. Time was believed to be something that was constant. One of the most famous mathematicians and physicists in the world, Isaac Newton, was the one to say this. In his opinion, regardless of the speed with which you're traveling through space, Albert Einstein was the first person to refute this. He said that Newton was wrong. Time isn't constant. He claimed that time was like a river. Like water flows in a river. Sometimes it slows down. Sometimes the flow of the river speeds up. Similarly, the flow of time. Sometimes it slows down and sometimes it picks up the pace. Depending upon speed and gravity, time dilates when the speed of the object increases, or if an object is subjected to an increased gravitational force. Basically, time dilation can be done in two ways. The first is with speed. If you are sitting in an object that is going very fast, like an aeroplane or a spacecraft, the faster something goes, the more would time slow down for it, relative to a person who isn't going as fast. Suppose you have two clocks. I keep one clock with me and put it on the ground. And I send the other clock with you on an aeroplane. The aeroplane goes around the Earth once and lands back. If we then compare the two clocks, though the clocks showed the same time initially, but now the clock that you took with you on the aeroplane, the time it shows would be some nanoseconds behind the other. The two clocks wouldn't show the same time. Because one clock was traveling at a higher speed, it's subjected to kinematic time dilation. I'm not making this up. There was an experiment in 1971. Atomic clocks were used. Because time was to be measured precisely and it was seen that the clock that was in the aeroplane, the time it showed was behind that of the other clock. This was known as the Half-Keating experiment. This had proved Einstein's theory of time dilation. If we observe the clock on the aeroplane from the ground, time slows down in our relation. Because we're seeing it, time is slowing down. For a person on the aeroplane, theoretically, if we could build some rocket or spaceship in future that can travel with speed of light, we would be able to time travel. There isn't an aircraft that travels at this speed. You can get to the speed of light. But with improvements in technology, we can build more such aircraft and spaceships that can fly faster. There's another way of time dilation as said by Einstein. By using gravitational force. Similar to time dilation with speed, gravitational force leads to time dilation too. More the gravity, more would be the time dilation. Einstein asked us to imagine a fabric of space-time. Imagine a mesh, and put balls on it. You can think of these balls as planetary objects. The heavier a ball would be, the more this mesh would get wrapped. The more mass in the ball, in the planetary object, the more would be its gravitational force. Earth's gravitational force is less than Jupiter's. Sun's gravitational force is more than Jupiter's. Similarly, in the fabric of space-time, you get to see a curve with the gravitational force of an object. The closer you get to an object with a high gravitational force, the more would you feel time slow down. You can have an approximate estimate with this visualization. This basically means that, if you want to travel through time in the future, spend some time near Jupiter, or around the Sun, or near an object that has even more gravitational force. Like a black hole. What about the past? Can we travel into the past, realistically? As of now, we can't travel into the past, but we can get a glimpse of the past. Theoretically speaking, Einstein's theory of relativity doesn't disprove time travel to the past. Einstein had said that in the mesh of space-time, if a gravitational force is put on it, that is so heavy that the object falls through the mesh, it would create a wormhole. We can use that wormhole to travel into the past. Need an extremely powerful gravitational field, similar to the one of a black hole. Perhaps a spinning black hole can generate so much gravitational field that it bends the curvature of the space-time back on itself. It would create a closed time-like curve, known as CTC. You can try to understand it through this diagram. You can try to imagine it. Nobel Prize-winning physicist Kip Thorne believes that small wormholes get created and then disappear in space. But they are really small. Smaller than atoms. And if we want to travel through them, we would need to open them up somehow. It would take a lot of energy to expand them. Not only normal energy, but we would need negative energy also. Negative energy is a kind of anti-gravitational energy that would repel the fabric of space-time. Like the same poles of magnets repel one another. Negative energy would work in the same way to repel it. This would make it possible to keep the wormhole for a long while, and to travel through it. How would this negative energy be harvested? But when we talk about traveling to the past, there are a lot of hurdles. I'm talking about paradoxes, such as the grandfather paradox. The paradox goes like this. Suppose I go to the past while time traveling, and I kill my great-grandfather. If he dies, how would I be born? If my great-grandfather died, I shouldn't be alive. And if I was never born, I never existed, how could I have gone to the past and killed him? How do you explain this? This is a paradox. Either I'm alive or I'm not. This goes against logic. There are some theories to explain this, such as the theory of multiverse. The theory claims that what happened once was in one universe. But when you travel back in time and change something, it would create a new universe, creating a multiverse. So there are multiple universes, with different things happening. Related to this, there's another paradox, the predestination paradox. It claims that when I go into the past, and do whatever, everything I do shapes my present timeline. Overall, there would be many logical problems when traveling to the past. There would be paradoxes. Due to these, it may never be possible. But traveling to the future, it is possible, even today. Thank you very much.